Welcome to Coach Eichner's Math. Today we'll be talking about some trigonometry. Trigonometry will be very important as you're headed forward into your calculus days. So, real important, let's first talk about what is trigonometry. At our level, what we're going to do is it is going to allow us to use various mixtures of sides and angles of right triangles to find the missing pieces. Okay, what's really important here is you recognize that it's sides and angles, so it eliminates where we're at with just knowing sides, we're able to find angles. And it eliminates being Pythagorean theorem where we have to have two sides to find the third. And it eliminates only having special circumstances like 30-60-90s or 45-45-90s. This allows us to use a various mixture in order to find pieces. So the three things we talk about under trigonometry is sine, cosine, and tangent. There are three other options as well that you'll get into later on. But you'll find on your calculator you have a sine, a cosine, and a tangent button. So as we're looking at it, we know that the sine is the opposite over the hypotenuse. Or we write O over H. Our abbreviation, we say the sine is opposite over hypotenuse. The cosine is the adjacent. So we're going to write A over hypotenuse H. And the tangent is going to be the opposite over the adjacent. Notice these are sides of my triangle that we are going to label here in just a second. So let's look over at the side here. If we're talking about angle A, well, C is always going to be the hypotenuse. It will never change. The angle A, the side opposite angle A, would be side A. So I'm going to write an O over there. The side adjacent to angle A would be side B. So as I look at it, setting up a ratio for sine, opposite over hypotenuse, the opposite is A, the hypotenuse is C. So I would say A over C when I'm looking at the sine of A. Cosine of A. Now the cosine of A, we're looking at the adjacent over the hypotenuse. So there's still A, the adjacent is B, and the hypotenuse is C. So we'd say B over C. And then the tangent, we're looking at the opposite over adjacent. So the tangent of A is A over B. Notice that A or B here is talking about our angle. So we've talked about everything in terms of angle A. So now as we look at it, we're going to have to go back through and notice that now we're talking about angle B. Well, if we're talking about angle B, this side right here is no longer opposite, it is adjacent. And this side over here is no longer adjacent, it is opposite. So we have to change those two sides. Talking about angle B, sine of angle B is opposite over hypotenuse, or B over C. Cosine is adjacent over hypotenuse, or A over C. And the tangent is always the opposite over the adjacent, or B over A in this case. So we write that out as so, ka, toa. Sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So the important thing here is we know which angle we're looking at, and that's listed right next to the cosine or the sine. And we know which sides we are then able to use. So looking down at example number 1. Looking at everything in terms of A. This side would be my hypotenuse. In terms of A, this would be the opposite. This would be the adjacent. It is opposite because it's across from. It was adjacent because it is next to or touching. Sine of A. Again, sine is always so. Sine of A would be 5 over 13. Cosine of A would be 12 over 13 because the cosine is always the adjacent over hypotenuse, and the TOA, or the tangent, is the opposite over adjacent, or 5 over 12. So now we're going to do the same thing. We're looking at it for angle C now. So now we're looking at angle C, which makes this my opposite and this my adjacent. Notice how the hypotenuse does not change. It stays the same, as the hypotenuse of a right triangle can never change places. So, sine of C, opposite over hypotenuse. Sine is opposite over hypotenuse, so 12 over 13. Cosine of C, adjacent over hypotenuse, or 5 over 13. And the tangent is the opposite over adjacent, or 12 over 5. Take just a minute, see if you can knock out these next two problems without me. All right, I'm going to kind of move a little faster through these. Looking at W, it's going to be opposite, it's going to be adjacent, it's going to be hypotenuse. Now, the first issue you see is you don't know your hypotenuse. So if you do Pythagorean's theorem, 9 squared and 12 squared, that would end up giving you 20 for this side. Excuse me, 15 for this side because it's 3, 4, 5. So knowing that that's 15, we're going to say sine is opposite over hypotenuse, or 12 over 15. Cosine is adjacent over hypotenuse, which is 9 over 15. And then the tangent of W is opposite over adjacent, which is 12 over 9. So now to look at it the other way, we'll talk about x is our angle. If x is our angle, this is the opposite, this is the adjacent. So now that I'm looking at x, sine of x is 9 over 15. Cosine of x is adjacent over hypotenuse, which is 12 over 15. And the tangent of x is the opposite over the adjacent, or 9 over 12. Okay, looking down below. Again, saw two sides of a right triangle. Should have solved for our third one, which in this case is 30. Had to do a little extra math, and that's okay. Looking at it right now, this will be my hypotenuse. We're going to talk about L first, which makes this the opposite and this the adjacent. So as I'm looking at it, the sine of L, 30 over 34, which what you'll notice eventually is that is also the cosine of M. And then we're looking at the cosine of L, 16 over 34. Which eventually we're going to start noticing a pattern is the sine of M. And then finally, the tangent of L is 30 over 16, which is just flipped 16 over 30 when we get to the tangent of M. Flipping over onto the back. Now we're going to start putting it all together. Now that we know how to write the ratio, we're going to start using the ratio and typing things in our calculator, finding missing pieces. So, looking at this problem right here, I know angle 28. I'm looking for this side, which is the opposite from the angle I know. I'm looking for the hypotenuse, which is another piece that we can work with. So I'm going to come up top and I'm going to say so, ka, toa. So right now, looking for O, no H. Sine uses O and H. None of the other ones do. So I'm going to use the sine here. So I would say the sine of my angle, which is 28 degrees, equals opposite over hypotenuse, or x over 19. Multiply by 19 on both sides. And now is where you can put it in your calculator, because you can say x equals 19 sine of 28 degrees. But before you type that in your calculator, there's one important step that you must make sure you see. Every time your calculator gets cleared, it defaults to radians, which is another form of measurements of angles. We want to change that to degrees. So go over to where degrees is highlighted hit the enter button, and now that degrees is highlighted, go second mode to get out of that screen, and you are now in degrees, which means I can say 19 sine of 28 degrees, and just putting 28 in there, it knows we're talking about degrees, which in this case is 8.9199. So normally we round a couple places past the decimal, which if you look at this, it says round to the nearest tenth, which is one place past the decimal. So if I look at it, 8.91 is closer, 91 is closer to 90, so I'm going to say 8.9. So we're going to say here that x equals 8.9. And that would be my answer. I've just found the side of a shape, found the side of my triangle with one angle and one side length. This should work for any right triangle if you know one angle and one side. Looking at the next one, I'm not going to type this one in the calculator for you, but again, we're looking at opposite and adjacent, which means I would say that the tangent of 41 degrees equals x over 32. Again, same steps to type it in the calculator. You're just using tan button instead of the sine button. Looking at number 3. Know this angle. I know the adjacent and the hypotenuse are what I'm going to use to help me, which would make it a cosine problem. So I'm going to say the cosine of the angle I'm looking at, which is 21 degrees, equals the adjacent, x, over the hypotenuse, 26. So looking at the adjacent over the hypotenuse, multiply both sides by 26. I would end up saying in my calculator 26 cosine of 21 degrees is 24.27. Rounded would be 24.3. So in this case, I know that x equals 24.3. And that would be my final answer. Again, we're going to set up number 4. I'm going to let you work it out yourself. Right here, know this piece. Again, opposite's what I'm looking for. Adjacent's what I know. So I'm going to say the tangent of 55 degrees equals x over 8. Okay. So there you go. That's simple. You'll give you the opportunity to work that one out on your own. Looking on number 5. Again, and know the opposite. Looking for the hypotenuse, O and H. That would be a sine problem. So I'm going to say the sine of 33 degrees equals 15 over x. So when I look at this problem here, I'm going to multiply both sides by x. And then I'm going to divide both sides by the sine of 33 degrees. X's will cancel. The sines will cancel. I'll say x equals 15 over the sine of 33 degrees. So I go to type that in my calculator. I say 15 divided by sine of 33. Make sure you close your parentheses up. 27.5 is my answer. X equals 27.5. Okay. So again, the advantage of trig when I ask later is going to be that I can use sides, I can use angles, and I can use a combination thereof as opposed to having to know all but one like we did with Pythagorean's theorem or knowing special case scenario like we did with special right triangles. Take a moment, pause the video, see if you can do these next problems on your own. All right, welcome back. I'm going to talk to you real quick. Looking at hypotenuse, looking at adjacent, that's going to say it's cosine of 43 degrees equals 36 over x. So the way that one should be set up. Looking down at number 7, we know 72, which means we have the adjacent and the opposite. So knowing the adjacent and opposite, we'll say tangent of 72 degrees equals 25 over x. Looking on to the next one. We know the adjacent and hypotenuse is the pieces that they talk about. So we're going to use cosine. We'll say the cosine of 64 degrees is x over 11. Okay, and the next two, I'm going to go into more details, but I'm going to do it in a separate video so that you have the opportunity to see it all. So please take this moment. Hope you've had a great rest of your day. Thank you for watching.